Okay, so after we import STL here in Blender, this is what we get. Make sure we're in this mode right here, because the other modes you can't really tell what you're doing. And then for wireframe, we can click on here to see the density. Okay, and down here is where your indicators are. I was expecting it to be displayed somewhere like in Max, and I spent literally 2 hours looking for a display somewhere out here, but it's all down here. I haven't been able to figure out how to like if you have two objects, how to have one selected and it will only display the selected. It just displays everything. So we'll have to figure that out. Okay, so this is the 4 million face right here. Freecad, which is the other software, I've tested the limits and it seems to do up to between 2 to 400,000 faces okay. Anything more than that, it just seems to stall all day. So I don't know if it's a RAM problem or CPU or something. We have to figure that out. But so anyway, to bring it down to from 4 million, so there's two ways to do this. If we click on this wrench here, we can add a modifier, and it's called the decimate modifier. This is kind of like the ProRes modifier in Max. Decimate here. So these are the modifiers. Click on that. And there's 3 modes. I've tried these, but this one doesn't seem to work yet. I haven't figured out. This one takes a long time. And then it does a weird face. But I think ratio is right now. So if we say 0.1 is 10%, that will bring it down to 400,000 faces here. And press enter here. And it will take a couple minutes here to update here. And then you'll see that this will jump down to 400,000. So I guess if you want to see each individual object, you can add a modifier here, and it will count it for you. But that looks like a clumsy way to find out. Or I'm sure we can rewrite some kind of script here to add another display somehow. We'll figure that out later. So okay, so ratio, you'll see that it's 400,000 faces. And if we turn this off, so this is what we're dealing with now. So the question is, can we send this to CNC or not? And then you can hit Control D and duplicate this. And if we hit Control D and if we see the x-axis here, we can hit X in Blender. So Control D to duplicate, and then X means that it will drag it in the X direction here, so you can have two side by side to compare. So that's what I was doing to test. Hold on here. It takes a little bit of time to copy the second guy over. Okay, where's the other one? Okay, where's the other? Okay, there it is. So you see that it's moving on the x-axis. So okay, so now for this one, I'm going to turn off the modifier here. So click on this to turn it off, or erase. So this one doesn't have it, and this one does have it. So you see that they look pretty good, the decimate modifier. I'm going to turn on the wireframe here. See, so you see that this is a lot thicker, right? Mm-hmm. And this is a lot thinner. So okay, so so at 4 million, the original one that we got, and versus this, I think sooner or later, if we're gonna do CNC, we're gonna have to sand it anyway because of this. So it's possible. But for quickness sake, I'm gonna go down to only say I'm gonna do it really low because I'm gonna bring it into Freecad to show you guys. So this is gonna be a really low setting here, but so that Freecad for this tutorial we can play, or I can show you in one video what it looks like. So. And you see, even at this low level, it is low, and I think we need to go a little bit higher, but even then, it's not too bad. So I'm gonna pause the video. So yeah, I mean, you could rebuild this, I suppose, if you use a model like this and then rebuild it, right? Depends on the modeler how long it would take to rebuild something like this. But this is at 80,000 polygons. The only thing about the decimate is if you go too low, which we'll see here, is that you start to get this surface here. And then the question is, do you CNC, sand the CNC of this, right? But it still retains a pretty decent shape. And especially if you consider that the model will be about roughly this big in real life. So, the details here might not be too bad, right? Because, yeah, from here to here is about maybe 7 centimeters or 10 centimeters. however that is. Okay, but so that's the decimate way, right? And then the other way is if we how should I do this? I'm gonna apply on this here. Okay, and I'm gonna Control D. Let me open up my screencast keys here so we can see here. Okay, so I'm gonna select this one and then Control D again, and then X. And then, okay, move here. Well, that was quicker. Okay, so now I have 3 models. Now for this one here, I'm going to use a different method. So this one was the decimate modifier. Here, if we go down to, where is it at? I can never find this. Okay. It's called the remesh. I hate Blender. It's got like 10 buttons. What's it? No, that's the for modifiers. Blender's got, Max has an, it has like only 5, which is, good. But when you start to have so many, oh my God, it takes a while to get used to where things are. Okay, so where is it at? It's called the remesh somewhere in here. Oh, here it is. Okay, so it's under this thing. I guess it's the object properties or something. Object data properties. Okay, so it's this. All right. So under here, the remesh, there's different types. I've seen the voxel work. The quad doesn't seem to work on triangle. Only if it's a quad, then it can work. But anyway, the voxel size, the default one does a pretty good job of retaining it because that's how many, it will create a voxel square box of 10 centimeters and try to rebuild it through that way. One for this model seems to be okay. But again, for quickness sake, I'm going to do a higher one, so say 0.2 here. Okay, so the bigger this is, the more lower resolution this is. It's like Minecraft resolution. So I'm going to click on voxel remesh, and then let's see this here. So you see that this is a different system. This does actual quads. Again, this is so you can see the difference. Now again, this is 0.2. When I did the other one 0.1 or 0.15 or 0.0, a little bit lower, then it came out really pretty decent. Like it looked just like this one, but with only like 400,000 polygons, right? But again, just for the sake of this tutorial, I'm gonna undo this, and I'm gonna do. Let's see, how many faces is this? Oh, we don't know, huh? Yeah, if you do this, it's hard to say which one. But I guess for the sake of this tutorial, I'm going to bring this one into Freecad, so it's quicker, because otherwise it's going to take forever. But yeah, so it's a really tight balancing act between how low can you go and what can you sand once you get the aluminum or the mold. What can you sand in the CNC? But I think even with something like this, oops, was it already done already? Okay, let me redo. Let me Control Y. It counts the selection as a function too, so sometimes you have to do redo twice or 3 times. I'll just do it again. Okay. Okay, so yeah, I'm gonna bring this guy in. Okay, so again, this is going to be low resolution, but for quickness sake, I'm going to bring it in. All right, so I'm going to select this guy, export, export here, STL again, and we could just save it somewhere out here. I'm going to say this one's reduced. I don't know how many faces this is. It doesn't show. But I'm going to say I'm going to call this reduce point 02, right? 0.2, okay. And this, what system was this? This was the remesh. Okay. Export STL. Okay. Now, there's a software, and I think upstairs you already download it. It's called Freecad. Okay, so Freecad is the other part of this. So Freecad software does a really good job for free software, even of importing this. Okay, so this is Freecad when you first open up Freecad. You can download version 1.8. So I'm going to, it's already new, but I'm going to click on Open, and then I think we saved it in the D drive, right? The D drive, Oka. I think reduce remesh. So this one here. So open up this one. Oh, it brought in all three. Shoot. Okay, so obviously I'm going to delete these then. Okay, let's re-export it back again. So it doesn't have export selected, huh? That's okay. Okay. Let's bring back this up. New. Import back in. Okay, so there 13 minutes. Okay, so that's quick. What? Oh, okay. All right. So again, we can see the was it the shaded or the wireframe? See how thick it is, right? So essentially, what this software is going to do is it's going to take this mesh and then just draw splines, G code of where the path will go in CNC. But to do that, before we have to do that, we have to go to mesh design. And when you do mesh design under meshes, there's an analyze this, okay, repair. So sometimes when you create stuff, it will give you like errors where it can't convert. So this prepares the mesh and makes sure that it can. So you can click on this and it will go through each of these here. Just make sure you have this selected. So click analyze and it's going do. So there are some of these problems here. So we could say repair. So repair. Okay, let's analyze again. So you do it a few times until it's all gone. Repair, and analyze again. And if everything is clear, we're good. Okay. And once we repair everything, we go to change it to part. And select this guy right here and go to part, create shape from mesh. So this is the moment of truth. If this happens, and leave that at 0.1 tolerance. I haven't really had time to experiment with this, but I suppose the smaller this is, then the smaller it will draw the path lines. But the tutorial said just leave as is, so I left that is and click OK. And after a couple minutes or however long, it will say successful, and then you export out an STL, and that's pretty much it. So STP, I mean, I'm sorry, yeah. So the question is, on my computer at the moment, it seems like 200,000 or less takes about 40 minutes or a half hour to do this, and we have the STL, and then we can send it to the CNC guys and see if it works, and then from there we can sandpaper this. So I think this is a very viable way to do this. The other way is we can start to design, in Rhino or whatever, because they have those paths that export straight out too. Either or, so either we get really good at remeshing, or we start to think about modeling in Fusion or Rhino. But but I think for modular, simpler toys we can do that. But for toys like this that comes from ZBrush, this I think is a pretty good workflow. It seems to be good for us. And even if we have these defects in CNC, we can have someone sandpaper this or sand it down, which I think will save us a lot more time than casting metal. So yeah, once this is done, you just go to File, Export STPE. Okay, so ask why is there a defect here, not here. So how does a voxel do this? Can you imagine a voxel is like a pixel, but in 3D space? It's just a square, right? So when you say a 0.2, what it's doing is it's creating a volume of this whole thing of squares, a bunch of just squares, of 10 centimeters each. And what it does is it does a test. If it intersects with this guy, then create that volume there. If it doesn't, then don't. So that's why when you have like a curve here, and if it's a half and half thingy, then it will appear here.
Oh,
Yeah,
okay.
I think it will be more obvious if, for instance, if I do this and say, say one, even one here, right? So it's going to be 5 times rough. So if you click on voxel remesh here, you see. So you see where that bump, it explains that why there's a bump up here. See?
Okay.
Because yeah, it's not enough. So you start to get it over here because there's not enough resolution to cover that.
Okay.
Yeah.
So what about the rebuild the surface? So why would it take a long time? Can we just like delete this plane and then put something in and then let it like auto reconnect every vertex or something like that?
I don't know if there's any tools to do that. That's human level. That what you're saying is not an automated process. Or,
Yeah.
yeah. But yeah, I mean, what you're saying is, yeah, if humans or artists can jump in and do that, like yeah, rebuild this, and then it's possible. But this is more like an automated process. Like if we get stuff from our clients or from ZBrush,
Hmm.
you know, uh, what methods are there to automate it? Because if we get like a set of 10 or 12 different items, um, it, it's more efficient if we figure out automated ways first, and then only resort to human ways of doing things if we can't figure it out. But so yeah, I mean yeah, I mean if it's something that just no matter what we do, there's always that kind of mess up thing here, then yeah, then we go in and we use the humans to do this. Uh, okay, so the human would probably go into the vertex level here. Let's see here. And you could probably push this in more. The axis is way out there, so it's kind of hard to control this. See? So you can push that in just a little. So I mean, I guess if there's obvious ones, we can do a really low poly like this one, and if there's like a really obvious ones like this, we can spend an hour or two to fix a few of those. See? So I suppose we can do that as you know.
Okay.
It looks like she has warts. And I'm sure there's more powerful retopology tools, but for really complex ones, anyway, that's probably for a later discussion or a video on how to deal with that. But yeah, this is just purely for automated stuff. Okay. Okay, so after about 20 minutes, finally finished here, and so let's. If you zoom in closely, you can see uh, the path that it just recreated. Okay. So export. Let's see here. Where is our STP? STP here. With colors. So I imagine it's this STP right here. Got this leg. Okay. Oka. Leg. This was remesh. 0.2. This is open. Okay, so it's Okay, so we have to select the STP one and not this one. I had, okay, which one's the difference here? It's probably this one. This one looks like the reduced mesh here. Okay, so let's export. Okay, STP, save. Okay, I believe that's it. Okay, and then after exporting it about 5 minutes later, it was finally able to export. And I'm going to clear this out here, new, and see if we can bring in back our STP, which is this file right here, as a test.